Same question again. When does the Wronskian guarantee that its input functions y1 and y2 are linearly independent? So here our difference equation is y double prime plus y equals 0. Our two homogeneous solutions are y1 equals cosine of x and y2 equals sine of x. And intuitively, this should always be able to solve for any initial condition because the system represents a mass on a spring and there's no friction. So no matter what initial position it has and no matter what initial velocity it has, we should be able to solve for its behavior in the future. All right, let's just see what the Wronskian ends up being. So the Wronskian of these two functions, so we have cosine of x and sine x. All right, that's going to be the determinant of cosine of x, sine of x. The derivative of cosine is negative sine of x. The derivative of sine is positive cosine. All right, now to be very careful here, so I'm going to end up with cosine times cosine, so that's cosine squared of x, minus, I have sine of x times negative sine of x. That ends up being negative sine squared of x. All right, that ends up being cosine squared plus sine squared of x, which is just 1. Okay, so that makes sense. So the interval that we always have are able to solve for any initial value problem, x naught, is going to be negative infinity to infinity.